Okay, good evening, everybody. Welcome to this webinar by Came Club. Uh, I will request everybody to please mute their mics, and whenever you want to speak, maybe you can raise your hand because it will be disturbing for everybody. If you are not getting my voice, or if you will not be able to see the screen, you can raise your hand later. Yes, Chenchal, I can see your hand. So as long as the session is going well, please try to make it smooth. Let the momentum be continue so that we can have a undisturbed learning. So I'll share my screen. Let me know once it is visible to you. I'm yet to share. Just a moment. Okay, just somebody maybe tell me whether is it visible or not.
Yes, sir, visible.
Okay, thank you so much. So welcome to Came Club. As you many of you know, Came Club is a renowned name in the process design engineering field. So we are into process design engineering solutions as well as trainings. We have a very big portfolio when it comes to industries. So these are our services. We provide basic engineering and field studies, process modeling and simulation, process monitoring and troubleshooting, and advanced software solutions, which includes Aspen 1 engineering suite, where we have Aspen HYSYS, then relief sizing, then Aspen HYSYS dynamic, Aspen adsorption, solid modeling, Aspen air cooled heat exchanger. I'm just naming a few. So we have entire Aspen engineering suite, and we are in a position that we are able to handle all your technical queries, your design problems, and we provide with you the detailed solution for that problem. Okay. Uh, so I'm just going through few of the slides. We are having custom process solutions. We provide energy optimization, equipment design, safety, process troubleshooting, process simulation, and the last is training. Okay, so I will not take much time through this. You can visit our website, the Came Club website. There you will find all our services that we provide, our customer base, and our projects that we have done in past. So whenever you have next time any issue in your plant, maybe a greenfield projects or a running plant with some technical issue or some requirement in terms of training of your staff, please do reach out to Chem Club. Let us now start with our today's webinar, which is on pressure safety valves. Can you please confirm whether my screen is visible again? Maybe someone?
Yes, visible.
Yes, sir, visible.
Okay, thank you. So, yeah,
It's
why
not
pressure
visible on my
safety?
side.
If it is visible to someone, then the problem must be with your system. Try to reconnect or check internet connectivity. Maybe it may have some lag due to internet connection. If it is visible to one, it means it should be visible to all. So why pressure safety is important? Uh, I will share with you one explosion or one incident that happened in 2024 in US. It was in Jordan sense color explosion. Jordan is a big uh, manufacturer of flavors, fragrances, and such specialty chemicals. So in their plant on a particular day, they were producing carameled food product. Okay, so they have a
Sir, your mic is mute.
If it happens again, do let me know. If my voice stops coming in between, let me know. Thank you. So at 2:17 p.m., the pressure set point of the batch reactor was adjusted to 12 psi. So in US they use psi. We use in India or in Asia we use bar system. They use psi system. So 12 psi was the pressure which they intended, and the temperature set point was 300 Fahrenheit. Again, it's a FPS system, Fahrenheit, pound, and second system. So 300 Fahrenheit was the temperature set point at 2:39. So this was the situation at 2:17 p.m. At 2:39 p.m., which is approximately 22 minutes later, pressure in the reactor exceeded the set point. So it increased more than 12 psi, and there were attempts to reduce it. So attempts would be to stop the heating, provide cooling. Those attempts were made, and even though those attempts were made, the pressure safety valve opened at 2:54 p.m. So it is again 15 minutes after crossing that pressure. So because we know that the hierarchy of process control is, we first try to maintain the temperature by means of interlocks or logic, and if it fails, then pressure safety valve comes into picture. So at 2:54 p.m. the pressure relief valve opened. So as expected, the pressure initially decreased, but after it went off some of the material, the pressure again started to increase. Now the temperature also increased, and it reached 385 Fahrenheit, right? It was 300. Expectation was to have a 300 centigrade, but it reached 385 Fahrenheit, which was 85 above the set value. Okay, and 30 above the reactor's allowable limit, because when we design a reactor, if we want to operate at say 300, we will take some safety margin, and we would rate it at 50 55 degrees degree higher than our operating. So the design pressure was 355. The design temperature was 355 Fahrenheit. A few minutes later, the reactor catastrophically ruptured, and the pressure in the reactor reached 237 psi. Okay, so we wanted to protect the vessel. We had operating pressure at 12 psi, PSV somewhere around 20 or 30. The reactor actually reached 237 psi, and it ruptured. And the pressure at which it ruptured is actually 3 times more than the MAWP of the reactor. So this is a typical example of a pressure safety incident, or the incident which is possible when the equipment under consideration exceeds its design pressure. So my question is, why in this case do you think, instead of uh, PSV, when it pops up, instead of pressure going down, it increased, and the PSV could not protect the vessel from overpressure and rupture? What do you think? What could be the cause?
The scenario of overpressure must not have been considered.
Which pressure?
So maybe the PSV is undersized or
Undersized
not
PSV.
designed to not designed to the scenario that has been encountered in this case.
Right. So it is possible that the size of the PSV was not adequate, and that is why when it pressurized, it popped up, it relieved some pressure, but it was not sufficient to release the entire pressure which was getting generated, maybe because of the uncontrolled heating. So the causes may be multiple. We will see what are the causes of overpressure in slides to come. But to conclude here, maybe the heating rate is so high that the PSV is undersized. There may have been any thermal decomposition leading to generation of excess gases inside the reactor. and for which the PSV was not sized. So the cause, possible cause in this case, is that the PSV is undersized. So even if you have a PSV on a reactor, it is not protected until and unless you have a properly sized PSV. So the focus of today's webinar is to give you some background on PSV. So what the device is all about, what are its types, and to have a case study at the end to demonstrate how a PSV is selected. Okay, so when we say selected, why we say selected and why not designed, that also we are going to say, going to look at in the slides to come. Okay, so these are your pressure safety or pressure relief devices. There are PRVs, pressure relief valves, emergency vent valves, which are generally installed on a big storages. Uh, then you have rupture disc and breather valves. So breather valves are also safety relief devices. They are low pressure safety relief devices. So where the design pressure of the equipment is quite low, less than zero point 0.5 bar, we do not use PSV. We use these breather valves, and they provide the same protection against overpressure as the pressure relief valves. A question again. We will keep this an engaging session and not a one-way communication. So another question is, what do you think is the difference between pressure relief valve and a pressure safety valve?
Like relieve liquid and pressure safety valve relieve gases and vapors.
Pressure shift are directly open. PRV are gradually open.
Hmm. PRV?
Gradually open
Gradually.
when pressure is increased. Gradually open.
Right. So both of the
Sir,
points are
pressure relief valve generally used for liquid air, and
correct.
pressure
Sir,
safety
actually,
valve used for gas purpose only.
Correct. Correct.
Hello,
sir,
sir.
pressure
So
safety
Hello.
valve, I think,
yeah.
Yeah,
pressure,
PRV basically main difference on the design basis on a seat, and just like for in PSV pressure inlet pressure strike to one point, and that's reason due to design in trapezoid bottom is a triangular shape, and in PRV the our seats is I mean like
Broader.
circular shape, circular
You
shape.
are
So
you want to say that
the
they are
pressure,
broader.
yeah. So their pressure distribution is overall is same in PRV. So that's reason linearization is happen. It means that the flow with respect to the pressure. So this is a main difference according to my point of view.
Okay, so ultimately, the 2 points made initially, in the last we talked about internal design of the seat, which is different between PSV and PRV. The output that causes is PSV is a pop action, so it opens very quickly, it releases pressure, and it is used for gases. PRV is a kind of a proportional response. So as the pressure increases, is its response is proportional to the increase in pressure. It lifts gradually, and it is used in the liquid service. So mechanism wise, if you see, both are like spring loaded action. They act uh, uh, against incoming pressure on the seat. When the pressure increases, the spring compresses, and there is a cavity formation releasing the fluid, which might be gas or steam for PSV, and liquids for PRV. Okay. The second is rupture disc. So there are also two types of rupture disc. One is a concave shape, and another is convex shape. Okay, does somebody know both the types? Is there someone who knows types of rupture disc?
yes, sir.
What are the two types?
Forward acting rupture disc, that is concave, and reverse acting, that is convex.
Yeah, reverse buckling. So forward acting and reverse
Okay.
buckling. So what do you think is the difference
Sir,
between
I
these
have a
two?
question on PRV
Hmm.
that actually when we are using nitrogen blanketing systems, or
Hmm.
the pressure regulatory systems, we use PRV to reduce pressure in steam, nitrogen, and hydrogen also. So is it same PRV or there is some difference in it?
Okay, we will try to take questions at the end, but now as you have already asked the question, there are two nomenclatures for PRV. Like when you say PRV, it either mean pressure relief valve or pressure regulating valve. So where you are talking about nitrogen skid, if you are talking about the one which controls the pressure, like a control valve, then it's a pressure regulating valve. It is followed by a pressure safety valve that if the pressure regulating mechanism fails, then this pressure safety valve will release the excess pressure of nitrogen or steam. So PRV, there are two contexts. One is pressure regulating valve and one is pressure relief valve. So we are today talking about pressure relief valve and not the regulating ones. Okay. So if you have any questions, we can have them at later, because it will not disturb the flow of the webinar. Okay, so we were talking about rupture disk and we got the answer that there are two types. One is forward acting and the another one is reverse buckling. Can somebody tell me when do you use forward acting and when do we use reverse buckling?
Yeah, it's basically used in the pressure and vacuum system. It is.
Okay, so one answer is pressure and vacuum system. So if you can have a pressure and vacuum on the upstream side of the rupture disk, then you will use which one?
Yeah,
Forward
convective,
active.
The reverse buckling.
reverse buckling.
Reverse buckling. Okay, because it is somewhat resistant to vacuum. So another
Yeah.
reason is forward acting rupture disc are more common. They are the first choice when we want to select a rupture disc, and they are bulged in the direction of the flow of the fluid.
Yeah.
The drawback with them is that they are prone to fluctuation. So if you are operating very close to the rupture disc burst pressure, somebody's mic is on, please mute it. If you are operating very close to the burst pressure of the rupture disc, so what is burst pressure of rupture disc? We say safety wall set value, right? So it is a pressure at which the safety wall pops up. For rupture disc, when it opens, the pressure at which it opens or ruptures is called as burst pressure, and it is generally installed on a pressurized system, so the normal maximum operating pressure is called as operating pressure. So there is a ratio called OP to BP, so operating pressure to burst pressure ratio. When you are operating very close to the burst pressure, for example, the equipment is designed for 50 bar gauge, okay, and you want to operate at 48 bar gauge, so it is very close, right? At that time we use reverse buckling because it can handle.
You're on mute. Can't hear you.
Your mic is
Your mic is muted.
Sir, your mic is off.
Sir.
Why this happens, so but this keeps happening maybe after 10 minutes. So next time also give me the same reminder. So I think I was talking about the difference between the forward acting and reverse buckling. So forward acting rupture discs are general and they are used when the difference between operating and burst pressure is large, and when the operating and burst pressure are very close to each other and there can be a spike. My mic is on, right?
Yeah, you are
Yes, sir.
audible.
Yes.
Yes, sir.
Yeah, so when
Yes, it is.
when the operating and burst pressure are quite close to each other, we use the reverse buckling disc so that the spikes or the pressure fluctuations do not rupture the disc, because in case of forward acting there have been many cases of premature rupture. So if you are using reverse buckling, because of its shape, it absorbs some of the shocks and it does not prematurely rupture. So that is the point of selection, that it is generally more than zero point 0.9. So if your operating to burst pressure ratio is more than 0.9, you go for a reverse buckling rupture disc. Otherwise, you can use forward acting. Okay. All right. Next one is emergency vent walls. Those are installed on big storages. As you can see, they are weight loaded. On one end, you can see there is a black colored weight. So it is similar to pressure relief valve, but it is not spring loaded, but weight loaded. And another weight loaded device is breather valve. Okay. And we just discussed that breather valve we will use when we have a low pressure set value application, typically less than 0.5 bar gauge. Okay, let's move ahead. Why pressure safety devices is important? As we know, there are many instances where the reactors or the equipments are under pressure in normal operation, or they can be subjected to pressure because of process deviations. And to prevent the rupture, there are few options. Like you can have a interlock, you can have a safety relief device. These are generally the two choices. And comparing both of them, if your plant is, say, not very hi-fi plant, you are not having SIS system already in place in the plant, the best option to go is having a PSV or a rupture disc, or the combination of both. So that's why pressure safety devices are important for reducing the risk of explosion, inventory loss, and the incidents. They are quite reliable. So in general, it is said that PSV have a PFD of 1 into 10 to the power minus 2. So it is as good as a SIL 2 rated interlock, unless and until it is selected and maintained in the expected manner. If you are having a wrong selection, you do not maintain your PSV, it can malfunction and it will not give you required risk reduction. And it might lead to an incident if you have a frequent cause that causes overpressure of your system, and if your PSV do not act or the rupture disc do not burst, that might cause a big incident. And that's why not only the right selection, right design, also right maintenance, replacement is also important when we talk about pressure safety devices. Their cost is lower compared to HIPS. HIPS is high integrity pressure protection system. It is similar to SIS, where we use sensors to detect spikes in pressure or pressure increase, and stop the causing factors like a on-off wall or pumps, whatever. It is as good as a SIS. So lower cost is because the systems where you do not already have a SIS system, to install a new one, it is costly. Also, to maintain that, you need a very costly elements. You have to do TDS calculations in terms of PFD, availability, many things, life cycle management. So PSVs are simple compared to SIS.
Sir, I have one question here regarding the selection of rupture disk.
Mhm.
So basically, let's say we have situation in one reactor it is, and in that
Mhm.
reactor there are several recipes are taken for the products, and one is in the vacuum, one is in the pressure, one is in the atmosphere. So in that case, for the rupture disk, do we need to consider a high pressure or high vacuum side? Means if any recipe there is a high vacuum side, then we have to, means how it goes then in the choosing of the rupture disk on pressure point of view. Are you getting my, sir? Hello, hello, sir, you are not audible.
I got muted again. I'm sorry. I got your question. You want to
Yeah,
ask that you have a system where you want to take pressure and vacuum both in different
yeah,
batches. In one batch, maybe
yeah,
under pressure, other maybe under vacuum.
yeah,
So in that
yeah.
case, if you want to go only with the rupture disk,
Hmm.
you have to talk to the vendor that this rupture disk is going to get subjected to full vacuum in some cycles. Okay,
Yeah, but
and
again,
it
the limitations of that vendor is vacuum limitation is there. Means that all the rupture discs are cannot operate on 50 torr itself. They have range
okay.
something 600 or 500. So in that case, how we can be proceed? Means whether we need to take two ruptures disc and isolation wall, or how it should be.
No. Taking two rupture disk is not the solution. Ideally,
Okay.
because you are having a system which can be subjected to pressure. Ideally, you should use a PSV rather than a rupture disk because you want to also cater for vacuum. This is one option.
Okay.
Second option,
Okay.
if you are having the problem that okay, PSV selection is a problem because the material is corrosive, I need a rupture
Mm-hmm.
disk
Hmm.
in on the upstream of the safety wall. In the pressure
Okay.
case, what you can do is you can change the your control mechanism from when you are changing from pressure to vacuum. So when you are going for a vacuum process in the same reactor, you can isolate
Okay.
the rupture disk nozzle because you do not require it in that batch. Okay,
But
so
usually, sir, in the automated plant, it won't happening means the HAZOP will not allow itself for this type of preparation.
so HAZOP will allow it if you are having those batches, say one after the other. Like for example, you have a
Okay.
campaign, right? You generally have a campaign.
Yeah.
So you have
Yeah.
a campaign of a pressurized product. After the campaign is over, you have a campaign of a vacuum product. So when there is a campaign
Yeah.
for a vacuum product, you need to have a
Okay.
changeover. I'm getting a lot of noise from your end. Can you mute it? I got your question. I will try to answer. Yeah. So
Yes. Yes. Sir.
when you are shifting from pressure to vacuum, isolate those system. You can have an administrative procedure because see, it's an example of multi-purpose plant. So in multi-purpose plant, we do many changes, right? And the PHA is not sufficient, or it does not have sufficient engineering safeguards to cater your manual changes in the plant. So what you can
Okay.
have a change your checklist, which is under 4 eyes, that it will be checked by two people signed off that whenever this operation will be under vacuum, isolate this rupture disk so that it is not subjected to the vacuum, you can say vacuum effect. Okay, you can have that. And if you are having checklist in 4 eyes, as a product change your checklist, you can do that because there are many such changes which we do. For example, we connect different tanks for different products. They are also admin controls.
Mhm.
So in some cases you do not always have engineering control. This admin control is okay to have.
Okay. Okay.
Okay.
Okay. Understood. Understood. Means only the time of changing the recipe, we can have a control of the mechanical walls itself, or
Yeah,
we can see a,
you can
on off
lock.
wall.
You can lock.
Yeah.
No, on off wall is not the right choice, because if you have on off
Okay.
wall, because of the failure of those on off wall, your
Yeah. 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 Correct. Correct.
devices can go isolated in your required case also. For example, you are operating
Okay.
pressure batch. If you install a on off wall which is air operated, now it is air failed to close, and for example
Okay.
the air of that particular wall fails, it will close, it will isolate your process safety devices. So that is not allowed,
Okay.
right? You have to do it
Maybe in that case,
manually.
we are having the option of lock wall also,
Yeah,
wall locking system.
manual locked walls. Yeah.
Okay. Okay.
Okay.
Thank you, sir.
He-
Understood.
Hello, sir.
Wait. Now let us complete the presentation
No,
first. I will.
it is just in the continuation of this discussion. Can we use a PVRV in this case? That's it.
So PVRV is a breather wall, right? Pressure vacuum relief wall.
Yeah. PVRV is a vacuum pressure vacuum
But
relief valve,
but
which
he
can in turn be connected to a nitrogen supply.
correct. I got
And
your point.
yeah,
But in his case, in my opinion, because he is already having a PSV, so there is a requirement
Yeah.
of PSV
Exactly.
at a higher pressure, right? So PVRV you cannot operate at 2 bar, 3 bar. It is in millibars. Okay. So
no, I
pressure,
mean the
because it's
Means
a
when
weight
it is
loading.
the emergency situation. Yeah.
PVRV can be used in the vacuum situation. See, in pressurized situation, we have a PSV which is set at XYZ per set pressure, right?
But he
I'm
wants to pull
just
vacuum. He wants to pull
yeah.
vacuum. So when he will pull vacuum, there will be air ingress from the vent port of the vacuum side. He wants the vacuum
Exactly.
inside the
Exactly.
system.
Okay.
You
Okay.
understood the
Okay.
point? He
Yes.
want to
Yes.
have a
Yes.
vacuum. He also want to have the rupture disk, which is not suited for vacuum. If you provide PVRV, it will lift itself and it will allow the air ingress or nitrogen ingress inside. So he will not be able to pull the vacuum.
Correct.
Okay.
Got
Sir,
it.
Yeah.
just information, we are using one torr vacuum in our plant and we are using ruptured disc also, but from that ruptured disc, it doesn't buckled up.
Right.
I
So
don't know what it is.
there are suppliers which supply this reverse buckling type for full vacuum, but in his case, maybe the MOC is such. For example, you must be using the metallic rupture disc, right? So there are some rupture discs which are made up of graphite, so they are also not rated for full vacuum. So
Sir,
it
we are
changes
using
from,
PFA coated.
yeah, you are using PFA coated, but it is metallic with PFA coated, right? So PFA does
Right,
not
right.
give it PFA does not give it the vacuum rating. The metal part which is behind it, which might be the SS, it gives the vacuum protection. In his case, he might be using different MOC or some. See, it is also that what is your set pressure for that rupture disk? It must be very high.
2.5,
Yeah, 2.5
bar gauge.
for pressure side,
Yes,
and he gives it for full vacuum.
yes.
Okay, so maybe you can put in chat the supplier. The other person can take advantage and replace his rupture disk if it is a metallic one is accepted or the PFA lining is accepted. Okay, I was just telling with his drawbacks or with his limitations what can be the solution. Okay.
Yeah. Yeah.
Okay,
Thank you so
so
much.
what are the overpressure scenarios that are considered in API 521? API, most of you know, is American Petroleum Institute, and it has a series of standards from API 520 to API 528, which talks about sizing, selection, construction, working of pressure safety valves or pressure relief valves. And for breather valve, the standard is API 2000. So API outlines various overpressure scenarios like blocked outlet, fire exposure, thermal expansion, control valve failure, reactor runaway, and gas blowby. So whenever you are sizing your PSV or rupture disk, you have to identify which is the contributing or you can say credible scenario for your case. So you might have multiple scenarios where you have blocked outlet as well as fire exposure. So in that case, what you will
Sir,
do? So if
PPT is, so we are not able to see PPT,
I'm sharing, nobody is able to
but sir,
see.
not able to.
Visible. It is visible.
It is visible,
Visible,
sir.
visible.
Yeah, I can see it
Visible.
sharing. It may be the internet connectivity. Try to reconnect. Yeah. So what to do when you have multiple scenarios? For example, for sizing a PSV, you have a blocked outlet as well as fire exposure. So this is a very common one that you can have both the scenarios at the same time. So what you will do when you want to select a PSV which is suitable for blocked outlet as well as fire exposure? What is the procedure or what is the criteria for selection?
Need to check
Which the
that
relief
In
load
this
is
case,
high, that one
orifice
we
size is
select.
higher, in which case the orifice size is higher.
Okay. Mm, partially. Okay. Orifice size is, you can say, mm,
Depend on relieving rate.
see,
Depends on the relief load.
right. Relief load is
Relieving
the
rate.
right answer. Why? Because you can have different relieving rates at different pressures and different densities. So your blocked outlet, you might be having a different density because the temperature is normal. But in case of fire, you might be having a different density because it is under high temperature. So relieving rate is the right criteria because of in the same orifice size, you might get different relieving rates based on your different densities of the fluid, even though the set pressure is same. So relieving rate is the criteria. Whenever you are choosing a safety valve, first you have to make sure that you have considered all the possible scenarios out of this list. And for the worst case relieving rate, you will select your pressure relief device, either rupture disc or PSV or a combination of them. Okay. Okay, why combination is the best choice? So there are certain drawbacks of PSV. PSVs are come in direct contact with your process fluids. They are prone to corrosion due to contact of metallic parts with chemicals. They are prone to choking because it's a complex structure inside. They leak due to repeated working and or erosion of soft seats. So in case of toxic services, if they operate multiple times, you might have a situation that on the outlet side you have a small stream of material coming continuously. I have seen it in case of steam. You might also see in the plant that PSV outlet is always releasing some steam out of it because it's kind of leaked because of periodic strain on the parts. It is costly if constructed from special materials. So if you want to make it kind of Hastelloy or alloy 20, then it will be a very high cost. Okay. Am I audible?
Yes,
Yes,
perfect.
sir.
Yes,
Yes.
Yes, sir.
Okay.
yes,
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 sir.
yes.
Yes, you are.
Okay. So what are the drawbacks of the now these are the drawbacks of PSV, but whether the rupture disk takes care of all the drawbacks? No. When the rupture disk opens, the worst part is it de-inventorize everything. So if you have a say ammonia storage or ammonia reactor under pressure autoclave with high pressure, big inventory, if the rupture disk is the sole pressure relief device, if it ruptures and if it opens, your entire ammonia inside the reactor will be released to the atmosphere, and that will cause that will cause toxic exposure to a lot of people in the surrounding area. It will be a offsite emergency. So you do not want your material or chemical to get released to atmosphere. Even in many cases the material is costly also, so it is also a economical loss for the organization. Okay. Then as we discussed some time ago, there is always a problem that it can rupture prematurely if it is not selected well. If the forward buckling or sorry forward acting rupture disk is selected when the operating to burst pressure ratio is quite high. So if you are operating very close to the rupture disk burst pressure, there are chances, and there have been instances, I have seen at least 3, that the rupture disk breaks. The DCS shows that the pressure has not reached the burst pressure, but it breaks and it releases the inventory. If there is a pressure safety wall downstream of it, it would limit the relief, and that's why the combination is the best. Why? You can have a rupture disk which is made up of very high corrosion resistant material, which is costly, but because it's just a plate, just a thin plate, it the cost will not be very high as compared to a PSV. You should have a PSV downstream of that rupture disk. What it will do, if the rupture disk breaks prematurely, it will not lift. It will stay in its position because the set pressure has not reached yet, and because of that the de-inventorization will not happen. The LOPC, the loss of primary containment of the toxic material, will not happen. Second advantage is you can use a pressure safety valve which is not very costly, because rupture disk will prevent the corrosive material to enter the PSV for a long period of time, and whenever there is a requirement, the rupture disk breaks only at that short period of time. The PSV will be exposed to those chemicals, and in that very short time it is not expected to get corroded and malfunction. So this is the reason in many cases you must have seen a rupture disk followed by a PSV as a combination. They give advantages of both the equipments, while you can say discounting the disadvantages of both of them. Okay. What are the parts of it's a process? No, it's a pressure safety valve. There is a typo. So as you can see on the right hand side, its overall is the body. Let me see if I can use the pointer. Is my cursor visible?
Yes, sir.
Yes, it is.
Yes,
Yes,
yes.
sir.
Yes.
Okay. So this is the body, overall body. Here it is the outlet. This is the outlet of a PSV, and this is the inlet. Okay, I will try to draw it also. Okay, this is the inlet. From here your process fluid will come, and from here it will exit. So what will happen when the process fluid enters this thing, this cavity from the nozzle? It will apply a force on this in this direction that will compress. This is the spring. Okay, it will compress the spring, and because the spring is compressed, this will be lift in the upward direction, and from here the material will come like this and go to the atmosphere, or whatever system you are having. You might having a scrubber or any flare. It will move to that direction. This part is called as disc, which has a seat which is forced against this nozzle to prevent any leakage when the set pressure has not reached. There you have a adjusting screw. What it can do? Anyone? What is the purpose of this adjusting screw?
To adjust the
It will
set
adjust
point.
the set pressure.
Right. So you can tighten this screw. It will increase the force on the nozzle in this direction through the disc, and you have a higher set pressure. If you loosen this spring, the force in this direction reduces, and you have a lower set pressure. So this is the beauty of a pressure safety valve, that you can play to an extent. Remember, to an extent with the set pressure. You cannot change it uh, by any value. Okay, if you have say set pressure of 5 bar gauge, you cannot tighten the screw and make it 10. It's not the right thing to do. It's only a small tolerance that you can use it for whenever you are testing it. So for example, you want to have this PSV lifting at 5 bar gauge, but because of the aging of the screw, it has come down to say 4.8, and you want to increase it again to 5. You can again tighten the screw a bit and increase it to 5. But this is not the you can say recommended practice, to use one PSV for different set pressure by changing the screw tension. It is for only this small adjustment. Okay, so this is basically your overall construction of a pressure relief valve. Can somebody tell me which type this one is?
Conventional PHA without bellows.
Functional PSV.
Yeah, yeah. So this is a conventional PSV. So what are the other two types?
Pilot
Balance
type and
bellow
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 based
based
type.
and pilot.
Balance below.
One is conventional, balance bellow, and pilot operated.
Pilot operator.
Okay, so I will not go in this description totally. I will ask you the question. Uh, what is the difference between First, I will ask, what is the difference between a conventional and a balanced bellow safety valve?
The back pressure
Balance
scenarios
below.
act here.
Percent up to the set pressure and balance below is 30% of the back pressure.
Okay,
50% if it has to be corrected.
30 to 50 is the correct.
okay.
Yeah,
And
up to
pilot up to
50%.
50%.
What,
And pilots can
what,
go up to 99%.
okay, what is the difference in the construction?
The construction, there is
Uh,
the below seated in the disc area to
Mm-hmm.
increase the back pressure.
Conventional, the bellows are not provided. In
Mm-hmm.
bellows type PSVs, the bellows are provided for absorbing the pressure. And
Mm-hmm.
in pilot operated, the pilot, a separate pilot is provided through which internal pressure the pilot absorbs the pressure, and through the system's pressure the PSV pilot operates, and after the through the pilot the PSV starts in position according to the
Okay,
set
so
point.
okay, let us quickly go through. I think most of you have told it correctly, but for those who do not know at all, let me go through it. So this is a conventional relief valve. You can see that this is a nozzle and this is a disc set against it by means of this pressure. So when this PSV lifts this bonnet, This is called bonnet, where the spring is located. So this bonnet floods with the process fluid. Okay, so you imagine this as a hollow cylinder in which you have a spring and you have a piece attached to it with a soft seat against the nozzle. What happens when this lifts up? This is in smaller dimension. This has a smaller dimension compared to the bonnet. You can see the diameter, it is smaller in diameter compared to this diameter. So when this lifts, the process fluid enters this area. It also enters the bonnet, and it comes out from this outlet. Okay, it comes out from this outlet. This is the conventional safety relief valve. So in this, as you see, the spring is exposed to the process fluid. Okay, in the balanced bellow type valve, uh, the process fluid will enter this cavity, but it will not go in this bonnet section because there is a bellow which protects the bonnet from the fluids that are coming inside. As somebody mentioned, these bellows also absorb some pressure, and it acts uh, as a dampener. Okay, it acts as a dampener, and because of that, if you have a back pressure, so what is the back pressure? This is a PSV outlet. You can have this vented to atmosphere, or it might be going to some system where you can have uh, a pressurized system. For example, this is going to a tank, and that tank is, say, I'm drawing it, I'm not saying that this is the correct installation. I'm just trying to create a situation where you can have a pressure on the downstream system. So in this system, you can have a pressure here. So because we have a pressure here, it is called as a back pressure. It is on the back side of the PSV. This is the front side. This is the back side. So on this is called as back pressure. So there are three different types of back pressure. I will ask this question and expect an answer from you. So because of this pressure, what happens? The pressure applies on this disc, and the set pressure of the relieving valve changes, which is something which we do not want. It will also reduce the relieving capacity. Okay, so for conventional, we allow only very small percentage of back pressure, which is how much?
10%.
How much? 10%. So
10% under the
we are
set pressure.
correct. So whatever
No,
is the
but
set
even if
pressure,
the
so
back pressure is even if back pressure is high and it is constant, we can use conventional, correct? Because I
uh, so there is a problem in doing that. So as per the standard, if you have a back pressure which is more than 10%, it affects your relieving capacity. Okay, till 10% we allow it by code. If it is more than 10%, then there is a reduction in capacity of a safety relief valve, and for conventional we do not go for those options. Okay, there are factors. You can see the curves of capacity reduction, maybe KB and KC. There are some numerical examples at the end. I can show it at that point in time. So because the back pressure is high, the set pressure changes, that is one thing, but your relieving capacity is also reduced. So it is it is allowed to have only 10% back pressure. Okay.
That may be the chattering issue if we use the more than 10% back pressure for the conventional.
Correct. So one is chattering, second is you, because there is chattering, you do not get the required relief capacity, right? So for example,
Correct.
you want to release 1000 kgs per hour, but your PSV starts to chatter. So you will not get 1000 as a constant. You will get 1000, then 500, then 1000, then 500. So that reduces your effective relieving rate. That's why it is not allowed.
just one more query. If my back pressure is constant and if I know that my PSV relieving will always see that constant back pressure, even if it is greater than 10%, then I
Mhm.
can adjust that set pressure accordingly. Is it?
You can adjust that set pressure. Because of that, your relieving pressure would be higher.
Yeah.
That is okay. But if you see the code, in the code you have some overpressure scenarios, right? So
Yes.
you say that I will size for this valve as a 10% overpressure.
Yes.
So if you are sizing it for 10% overpressure, you already have 10% back pressure, more than 10% back pressure. Then your PSV size will be higher. You will have to select larger PSV size for getting the same relieving rate. Okay, and it is not the right practice to do. Okay, because code says if it is more than 10%, go for a this balanced bellow. There are reasons like chattering is there. You will have to make this adjustment that you will have to select a pressure which is lower than the MAWP, because you want to protect the MAWP. You cannot set the PSV at MAWP. You'll have to go for a lower pressure. Then if you are having a lower pressure than MAWP, your process pressure might reach PSV very quickly, and it may cause your PSV to pop more than what is required. So that all those aspects have been thought of while preparation of the code. So that is the reason they say no, do not go for conventional. But for example, you are operating a pressure vessel at 1 bar gauge. It is designed for 6 bar gauge. You can use it at say 3 bar gauge. You have that option that okay, I will install a conventional PSV at 3 bar gauge and let the back pressure be there. I don't worry because it is already sized for the relieving rate. It is set at such low rate that even the accumulation is not going to cause my MAWP to exceed. So that is something you will say as modified cases and not the standard cases. Okay.
Okay. Okay. Understood. Thank you.
Yeah. Okay. I'm not sure why I'm not able to go ahead. Some problem with my system. Yeah. Okay. So the next type is balanced bellow. In balanced bellow, the relieving pressure is not affected by the back pressure. They can handle higher back pressure. Why they can handle higher back pressure? Because you see, from here there would be a back pressure. There are these bellows which do not allow that entire back pressure to act on the seat like that, because they are protecting against this back pressure. So these bellows form a wall which prevents the outlet side from putting pressure directly on the seat, and that is why up to certain back pressure which is higher than conventional, they are allowed. And they also prevent the spring from corrosion. In conventional, we saw that when the process fluid enters here, it goes all the way into the spring and then comes out like this. So these springs are exposed to the process fluid. In this balanced bellow type, they are not exposed because there is a diaphragm here, there is a bellow here which prevents the direct contact of corrosive liquids or corrosive gases with the spring. Now question to all of you: there is a difference in construction at a point of this balanced bellow and the conventional one. What is that point of difference?
Sir, it
I think we
in
can't
balance
adjust
below
the
it
set pressure.
reduce.
We talked about we talked about the bellow, so that is the obvious difference from the name. What is another difference?
I think we can't
There is one
adjust the
vent in
set
the
pressure
bonnet.
by
Vent,
That's and
using
all.
vent,
spring.
bonnet
Yeah,
vent.
yeah, right. So this is the vent. Okay, so what is this? Why it is provided in both the cases, right? It is there in the balanced bellow as well as conventional. If you can see the previous slide, it is provided.
Yeah, but that time those
In balanced below, the vent will be open, and then
Hmm.
conventional that will be plugged.
Okay, so in conventional, this vent is plugged. It is given. Why it is given in conventional? So if there is some initial pressure, trapped pressure inside, you should be able to vent it and make sure that there is no back pressure acting on the disc when it is getting installed. Okay, so and it is venting to the bonnet and not to the atmosphere. So you, to make sure that the vent does not have any kind of accumulation, the bonnet does not have any kind of accumulation, you can just open it, check it, okay, and then fix it. In this type, you have a vent here. Why do we have a vent here? What if we close it?
As the bellows separates this spring, when pressure rises, then some air has to be vented from the bonnet.
Right. So it's not material, it's in normal operation air here, right? So if we do not put a vent here, this air will act against the bellow, and there will be additional pressure against this seat. One is from the spring, and the second one is also from the cavity or the air which is trapped, that will also pressurize, and that will cause the malfunctioning of this balance bellow. So the important aspect of this valve is that you should always have this open, and there are possibilities, there have been cases that this leaks, this bellow ruptures, or it leaks prior to the set pressure of PSV is reached. And uh, if that happens, there will be some release from here also. So generally you will route this stream to a safe location, right? But if it is a service wherein you can expect extremely toxic gas like say chlorine or HCN, hydrogen cyanide, or some HBr or bromine, then you should locate this vent at a safe location, or you should have some kind of identification that when this PSV is popping up, you should not approach the PSV because you will be exposed to this gas as well. So this has to be taken care when we are selecting a balanced bellow PSV, that okay, this is also a mode of failure that bellow might rupture and you might have a release of toxic gas from here. Okay, now let's move to the next type. My presentation is not working fine today. I'm not sure why. Yes, the balanced bellow.
Sir,
Somebody
you are not
explained.
visible.
I'm not visible.
Visible, sir.
No.
Visible,
Chat is
visible.
visible.
Yes, yes, visible, visible.
Okay. So if
Visible.
I'm not visible for somebody, he might have to change his internet connection again. Okay. So what about this pilot operated? Somebody explained it, tried to explain it quite well. Uh, this is a version where you can have up to 100% back pressure, that whatever is your set pressure, equal back pressure also you can have it. Why it is so? Because it is not dependent upon the spring or the cavity or anything like that. So what it does, it has a tube, it's called as pilot tube. So this is your main PSV. You can see my cursor, right? This is the main PSV, and you have a tube coming out from here, which is a pilot tube, and this is a control pilot, and then you have a tube going back here. So considering this side is always pressurized, this pilot is fed with this pressure always, right? So this control pilot, what it does, it has a mechanism wherein it gets the supply of this process fluid all the time. It compares it with the set pressure. Whenever the set pressure is reached, right, whenever the set pressure is reached, it actually vents, I'm sorry, it actually vents it actually vents the process fluid from here. And because of that, what happens, this equalization which has happened through the pilot, it changes. Now you have a pressure on this side, because this has been vented, you do not have a pressure on this side, right? So net pressure is acting in this direction, because you always have a pressure in this side, but because the pilot has vented, this pressure which was acting on the other side of this piston, it has gone. Now the net pressure is in this direction, so it pops up suddenly. Okay, as soon as this exhaust is out, there is a net positive pressure on this piece of metal, and it creates a cavity here, causing this relief. This is called as a pilot operated safety relief valve. This is used when you have a very high back pressures, or you do not want your set pressure to be affected by the back pressure. Also, it is useful for high pressures. So if you are using very high
But
pressure
the
PSVs,
back pressure should be from the outlet, right? Not from the inlet.
sorry,
Back pressure should be from the outlet, right? Not from the inlet.
I
You
don't
are saying
understand.
that continuous pressure is in the inlet, but back pressure should be from the outlet, right?
This continuous pressure is from the process. This pressure is through the pilot. You understood?
But how
There you have a
100% back
reactor.
pressure is maintained here?
I will tell you. So here you have a reactor, right? For
Yeah.
example, this system is set to operate at say 7 bar gauge. Okay. Now what will happen? This pressure is, for example, say 6 bar gauge. So what will happen? This 6 bar gauge will be distributed like this. So here also it is 6 bar gauge operating. Here also it is 6 bar gauge. So pilot, it is having 6 bar gauge pressure on the, maintaining 6 bar gauge pressure on the both side of this block, right? So this you see, you have a 6 bar gauge in this direction, 6 bar gauge in this direction. Following me till now? What
Yes,
happens
yes.
when this pilot
Yes, sir.
operates? What happens? It exhausts the pressure from here. So because this pressure is because of the process, it will remain as 6 because it is coming from here. As the pilot exhausts from here, it stops supply for here. The pressure inside the pilot is vented, and because of that, this pressure goes from 6 to say 0. I'm assuming 0. It will not go to 0 directly, but say let's say 1 bar gauge. Okay. So now what is the differential pressure? You have 6 bar gauge this side, 1 bar gauge this side. So it has a net 5 bar gauge pressure in this direction when the pilot exhaust. So generally in the normal operation or in the stable operation, it is having 6 bar gauge on the both side. So no net differential pressure, causing this to be in the same seat for all the time when the pressure is the process is operating normally. As soon as the pressure exceeds the set point, pilot acts, it vents the outside or the outlet side of this piece, the piston, and it creates a differential pressure, sudden differential pressure, which creates a motion in this direction, relieving the pressure. Is it clear now?
Yes, but what about the back pressure coming from the outlet?
This outlet,
Yes.
so this outlet will be there.
So the back pressure
I
comes
think we
from
have
there.
yeah, because like we have like two pressures coming in, which is from inlet and one and the back pressure from outlet. So but what if the outlet back pressure is coming like also 6 bar, then it will not relieve the load.
So it if this is also 6 bar, that is the question.
Yeah,
Yes, that's
kinda
what
like
it's me a
But
hundred
this,
percent back pressure.
yeah, if it is even though it is 100%, it is, see, it is not acting in the tangential direction. You see the construction, it is not only the set pressures, it is also the construction. Here you might have 6 bar gauge, okay, but what about the direction? You understood? The direction is like this because you see, you know the vector, right? If you are using a pressure in the tangential direction, it will not be acting the same as when you are using it in the straight direction. Okay, so tangential pressure is not always equal.
Yeah.
So
Okay, okay. You please continue. We'll see. We'll try to repeat something. We'll see at the
okay,
end. We don't want to
okay,
waste the time.
okay.
Hello, sir. I have one question. Actually,
Hmm.
sorry. A control pilot. You say that control
तो
pilot have
बंद
a
क्यों हो
set
रहा है?
pressure. Have a set pressure. Okay. So how much set pressure to
हाँ
be given for when the pressure is inside the six bar G?
Hmm.
How will which set pressure
देखो
in
इसमें
control
इसमें से
pilot?
भी गायब हो गया वो मैंने एंड स्ट्रीम किया तो
Hello.
I'm getting two
Hello.
voices. Yeah, continue.
हेलो
लिंक्डइन में एंड स्ट्रीम किया ना
Can
तो वहां
the
से
person
बंद
who
हो
is
गया
saying this end stream, can you mute, please? Hello.
हाँ
Yeah,
हेलो
please. Now
सर
you can
हेलो सर
continue.
हाँ
Yeah, you
yes
continue,
sir
please.
actually my pressure is 6 bar okay and
Hmm.
then so in control pilot how much will be set pressure?
Your set pressure is 6 bar gauge only. So this pilot will operate at 6 bar gauge.
Okay.
Once your set pressure is reached, this pilot will operate. It will create a differential pressure across this piece by venting the process fluid from here, and then you have
So it will
outlet
be a
from here.
set pressure. It means that your inlet 6 bar G and set pressure also in control pallet is also 6 bar. Okay.
Whatever is your set pressure, that will be the pressure
Mhm.
at which the pilot will activate.
Okay. Okay.
Okay.
Okay.
Okay, let's move
Sir, if
ahead.
both the pressures are the inlet pressure and the back pressure are 6 bar, will the PSU be effective?
Which pressure? Outlet pressure. It is not
I
acting
mean,
in the. It is not acting in the. It is not acting like straight. You see the
I,
construction, you will come to know.
I get it. I get it. You're saying that the vector, the pressure
Vectors
vector,
are in
which
the
is
different
yeah,
direction,
yeah,
and
but the
it is
contact
yeah
point of the vector will be horizontal only.
yeah
If we
this.
if mm,
So the you see that these guide rails are there, right?
yes.
So they will not allow this to push this in this direction. It will only be pushed in this direction because you have a guide rail here.
Okay.
Okay.
Okay. Sure.
Sir,
I'm not able to control. Let me just stop sharing. I'm not able to go ahead on the slides. Yeah. Okay. Yes. Is there a question?
Yeah. Sir, can you open that pilot PSV diagram once more?
Okay. Yeah.
Sir, the line connecting the pilot and PSV has a small size. So even if there is a small fluctuation also, then also the PSV will pop up?
No, there is no possibility of increased pressure even though the size is small. See, if you have a pressurized system and even if you take out a small pipe out of it, your pressure remains
Yeah.
the same regardless of your size of the pipe. Okay. So that is
Okay.
not going to change.
And the
Okay.
pilot getting the pressure from the PSV only, from PSV only where it is connected,
It
or
is
there is
getting
some.
it is getting the signal from PSV. There is additional supply of air or nitrogen to actuate it. Okay, it is getting that signal only.
Okay.
Yeah. Okay, so let us go to a case study wherein we will see how your back pressure changes your design. Okay. So this is an example, and this is an example from a refinery. It is also there in API. Okay, so you can also refer to the example when you want. If you go to API, there are calculations given. So in this case, the hydrocarbon vapor flow rate in case of an operational upset has been given as 3,500 pounds per hour, which is 24,270 kgs per hour. And the case is blocked outlet. Okay, so it has been given that this much load will be there on the PSV. The hydrocarbon vapor is a 50-50 mixture of butane and propane, and the molecular weight is 51. So this we will use as a data in the calculation. The relieving temperature is 627 Rankine, 167 Fahrenheit, and 348 Kelvin. The units are different. The value is same. The PRV or the pressure relief wall, here it should be like pressure safety wall, is set at 75 psi G. Okay, pressure's psi gauge, which is 517 kilopascal gauge. Right now, case 1 is when you have no back pressure, and case 2 is when you have back pressure of 55 psi gauge, and we are considering the non-fire case, and we consider overpressure as 10%. As you know, for non-fire cases we take 10%, and for fire cases we consider 21% of the set pressure as the allowable overpressure. So in this case we will calculate both the cases, that what size of safety wall will be sufficient. What is your gut feeling? uh, we will require the size of safety wall as same in case 1 and case 2. So the difference in case 1 and case 2 is, for the same mass flow rate we have a back pressure in case 1 as 0 psi as a gauge, as a back pressure. In the case 2 it is 55 psi gauge. What do you think, where we will need higher PSV, or both the cases would be handled by the same PSV? What is your opinion?
No, where the back
Case
So
pressure
two
is
higher
is
higher,
back
the
higher.
pressure, higher the size.
Higher the back pressure,
Higher the size.
so you mean in case 2 you will need a bigger size PSV,
yes.
Yes.
even though you want to relieve the same mass flow rate at same set pressure?
Yes.
Agree. Yes.
Okay, let us see whether your answer is correct or not. Okay,
Sir, no, sir, no, reverse.
reverse, what do you mean?
Actually,
Because the
I
back
think
pressure is the second case is higher, so area requirement is low.
Okay,
And
yeah,
also,
because it
since
would
the back
would
pressure is the high, the second case is the record the balance payload type.
okay, type we will
Because it
see.
is
Type we will see.
type will
Uh,
change.
type can change, but what about the size? Because you can have types determined based on different parameter, but size, somebody said that because
Second
there will
one,
be, second one is
second one
smaller or
has
bigger?
less differential pressure, so it will be bigger.
Okay,
It will not be bigger because it will it should be smaller so that the relief load can go out with the pressure if we decrease the orifice diameter, I guess.
okay. So
Sir, the
somebody is
orifice,
yeah, go ahead.
No, actually, it
if
depends
only
upon the
flow
relief
rate we
rate.
calculate the orifice dia, then it
Hmm.
should not be different.
Okay, so there are three answers now. Some people think that case 1 we will have a bigger orifice, bigger size PSV. Case 2, some people say case 2 have a bigger size PSV, and there was someone who said there will be no difference because we have a same relieving rate and same set pressure. So let us find out what it is. Okay, so let us first define, we will go step by step. So somebody who is seeing the calculation for the first time, even he will understand. Okay, so let us first define the set pressure and relieving pressure. We we have been given the set pressure, as you can see here, the set pressure at 75 psi gauge. We will calculate it in absolute. So the relieving set pressure will be your set pressure plus the allowable accumulation. So your relieving pressure will be 75 into 1.1. This 1.1 is because of the 10% accumulation, and this you will add this 14.7 to convert from psi gauge to psi absolute. So now your relieving pressure is 97.2 psi absolute. Now let us check the flow regime. This factor is called as PCF, critical flow factor. So uh, there are two types of regime. One is critical and one is subcritical. What is critical and subcritical? It depends on your this factor of PCF. So if your critical flow factor uh, is more than 56.1 in this case, The flow regime will become subcritical in case the downstream pressure of PSV is more than 56.1. So if your back pressure is higher than 56.1 psi absolute, then your flow will become non-critical, okay, or subcritical. In our case, there is, in case one, there is no back pressure, right? So the flow regime will remain critical. Is this point clear to you, or shall I repeat?
Yes. Can you repeat again
Hello.
this point?
Repeat, sir.
Okay, so we define flow regime. Flow. What is flow regime? What kind of flow will be there from a PSV? Whether it will be a fast flow or a slow flow. I'm trying to simplify. So critical flow is a flow. You are aware about. You might be aware about critical flow. It is the flow which is the maximum flow possible when there is a certain upstream pressure and some orifice area. So even though you reduce the downstream pressure, there is no increase in flow. That flow is called as critical flow. So even though so there is a orifice and there is a pressure upstream and downstream. So higher the upstream pressure and lower the downstream pressure, the flow will increase. But for a set upstream pressure, if you reduce the downstream pressure below a certain value, you will not get higher flow than a certain value. For example, the upstream pressure is 10 bar gauge. Downstream pressure you put as 3 bar gauge. You are getting a flow say 50,000. But now if you reduce it to 3 from 3 to 2, you get 70,000. Now you reduce from 2 to 1, still you get 70,000. So further reduction in the downstream pressure does not increase the flow. That is called as critical flow. So it has reached its limit. Okay, that flow is called as critical flow. If there
How
is
is it
a fact,
different from choke flow?
it is the same. So that's why I was giving the example of a control wall, but it's not that everybody would have studied the control wall. That's why I given it in a different way. It is the similar thing. They call it critical flow when it comes to PSV. So for our case, as the back pressure is not there, we are sure that the flow will be critical because there is nothing to think about. We will have a back pressure in the second case, and then we will compare the comparison of this critical flow and back pressure. So this is checked by means of this equation, where P1 is your relieving pressure. Then you have 2 divided by K plus 1 raised to the power K. K is your Cp by Cv. This ratio, you have this properties of gases in API. From here you can select your gas. I'm not sure what was our gas. Our gas was butane, right? So for butane, if you see, it is butene. It was 1.11. Okay, Cp by Cv. So our flow regime is critical. Now, for critical flow, this is for gas service. This is the equation. Okay, this is the equation. Now what characteristic we have? We have relieving pressure 97.2 psi absolute. Compressibility is Z, which is required here. Z is zero point 0.9. It is a calculated. If you do not have a calculated compressibility, you can use 1. In all the cases you will not be having this value, so you can use 1 as a conservative one. If you have a calculated value or available value, for our service it was 0.9, so we used it. Critical flow pressure from table 10, we found it as 97.2 into 0.585, so this is 56.9. Let me go back to show you the table.
So for checking flow regime, we have to compare it with set pressure or relieving pressure.
With the set pressure. Okay, so this is your critical flow pressure that we are referring to here. Critical flow pressure. Okay, this is the table in API. It is table 10. So for your gas, you can see what is the critical flow pressure, which is for our case it is 56.9 psi absolute. Cp by Cv, we discussed about it, and in table there is the value for C also. C also available, which is 328. So once you go through your API Six. This is five. I'm not sure. 521, I guess. Yeah, API 521. You have all this equation for you. You see this equation 6. You can see only alphabets here. C, KD, P1, KB, KC, T, Z, M. So you will come to know all the parameters when you go through. I will tell you T is temperature, Z is compressibility factor, M is molecular weight, W is your relieving rate. Uh, then you have this C, which is the coefficient which you can calculate by this equation. K, you know the ratio of Cp by Cv. Then you have P1, KB. KB is your back pressure, and capacity correction due to back pressure. This is KB. As we do not have any back pressure, we will consider it as 1. If we have some back pressure, you have to correct, you have to take this factor of KB. There is a graph available. So when you have a back pressure, you have to calculate KB also. And this is capacity correction for rupture disk. As we are using only the PSV, this factor will also be 1. So we were talking initially that we might use rupture disk and PSV as a combination. So when you are using that rupture disk and PSV as a combination, you also have to take a factor for KC. It is also available that around, I think it is around 0.8 if I remember it correctly, 8 or 8.5. So when you are using a combination of device, because it is not always that you will size for PSV. If you are having R rupture disk and PSV, you have to use this capacity correction factor for rupture disk, which is 1 in our case because we are not using it. Okay, this is the description of all the parameters that we use. So P1, which is the upstream pressure, KD is coefficient of discharge. When PRV is installed without a rupture disk, it is 0.975. If you are using it with the rupture disk, it is 0.62. Okay. Let us go to the calculation now. We have put our required mass flow rate from the case and other factors in here. Okay, we are not going to do calculation here. We just want to take the inference that what is happening when you have a back pressure and when you do not have a back pressure. So for case 1, when the back pressure was 0, we got an area of 5.73 square inch or 3698 mm square. We will go with inch square for simplicity. So 5.73 inch square for the load of 53,500 butane and without any back pressure. Okay. How we will select the PSV?
आ गया लेटर
How
मुझे
we
पता है
will
एसटीडीसी की 5 पीएसवी पी वाली है सबसे बड़ी
your mic is on.
इससे बड़ी होती ही नहीं है
Your mic is on. Yeah. So PSV, you can see here, it is denoted by means of letter, because there are multiple manufacturers who will produce PSV and they can produce it in different ways. So what they have to do, they have to assign a letter to their PSV stating that my PSV provides this much orifice area, and if the area provided by PSV should be more than the type which is assigned to it. So for example, any PSV with a type D should be having an actual orifice area more than, or effective orifice area more than 0.11 inch square. So for our case we want 5.73. So if we go down in this list, we will find, okay, for N we have 4.33, which is not suitable because it is lower than our required size. For P, type P, we have 6.38, which is higher than our required size. So as we required 5.73 inch square, type P, which is providing 6.3, is our selected type. So for case 1, when we do not have any back pressure, we have selected type P, which is 6.3. Now you remember this, when we will do the other case, we will have to again compare for the same case. So it's P 6.38. Now let us go to case 2. In case 2, we had a back pressure of 55 psi, right? So now you see the back pressure we calculated the back pressure as we were given the back pressure as 55 psig. We again checked the flow regime. We found out that PCF, uh, critical flow pressure, is 41.38 psig. Okay, so which is less than 55. So as the back pressure is higher than the critical back pressure, the flow is now subcritical. So now we have got the answer to the question. If the back pressure is higher, our flow regime goes from critical to subcritical. We are still yet to find out whether the size goes up or down, but we have now concluded that because there is a higher back pressure, the flow will not be critical. So flow will be slower. Flow will not be uh, as high as that was in the case 1 when there was no back pressure. It is obvious, no, because you have some pressure in one direction, on in the opposite direction you have some pressure, so the net flow differential pressure will be less, so your net flow will be less. So net flow is less, it means that the flow is not reaching to the critical flow and it is a subcritical regime. Okay, so we have to find a factor called P2 by P1, which is for calculation of F2, because you have this F2 as a factor for calculating the size of your PSV. So you have a graph here. It is also there in your API. So what the graph is about, you have to find P2 by P1. What is your P2? Your P2 is your back pressure and P1 is your set pressure. So you found out P2, you found out total back pressure as 77.2 and the P1 is 97.2, and the ratio of P2 by P1 is 0.794. Now you map it 0.79 on this graph and you will find out, and this is for different values of K. So for our value of K, when you plot P2 by P1 in this graph, you find F2 as 0.86. Okay, which is somewhere here, sorry, somewhere here. So this is our F2. This you can also use calculation. You can put values of K and R here and find out, but generally graph is the easy method. Now as you
Hello, sir.
changed,
Hello, sir.
as you yeah.
Sir, why we multiplied point 1 previous slide? A level back
uh,
pressure.
so see what can be your back pressure. You have 55 as your constant back pressure, right? But because of the flow,
Yes, sir.
you will also have some back pressure, which is 10% of your set pressure. Your set pressure is 75 psig, right? So your back pressure because of the flow which is allowed is 10%, which is 7.5. So this is your, you can say, dynamic. I did not touch upon the three back pressure: constant back pressure, dynamic back pressure, and superimposed, because we do not have much time to go through entire sizing. But this is the back pressure because of the flow, and this is your superimposed back pressure. So the total is, this is your total back pressure. So there are two types, one is three types actually: dynamic back pressure, superimposed back pressure. So you have to add everything to find out total back pressure, and this is your total back pressure. Okay, good question. However, you pointed out a good thing. So
This 55 is superimposed.
this 55 is your provided back pressure. So it is a constant back pressure downstream of your PSV.
Okay,
we
okay,
we
okay.
we, we were comparing it, no? So we
Yeah,
wanted to
yeah.
check whether the PSV size changes. So this
Understood.
55 is something which we considered.
Okay.
Now, as the flow has changed from critical to subcritical, equation also changes slightly. You can see that this factor has changed. F2 is included here. Now, we put in again all the values in this, and we find out what is our answer. The required area is now 6.55 square inch. Okay. Now 6.55 is here, more than P. Okay. So next available size is Q. You cannot select a PSV having a less than your required area even by fraction. So your required area is 6.55 inch square. So you need to select Q, 11.05 inch square. So what's the conclusion? The conclusion is the information about the back pressure on PSV is critical in sizing the calculation. There is increase in required size of PSV for the same mass flow rate because of the increase in back pressure. So if you have, I have seen many cases where you all are responsible for at some point in time procurement of PSV from vendor, because no chemical industry manufactures its own PSVs. So whenever you are filling up the data sheet, sometimes people make a mistake that back pressure, oh, zero. You need to go and see that where this is going to get installed, how much piping is going to run from the outlet, where it is going to get connected, is it in the catch pot, is it in some dipped condition under some water head, and you have to provide accurate back pressure to the vendor. Then and then only your PSV will be sized correctly. If you miss those points, you will end up having a undersized PSV. So that was our insight from this session, that if you have a if you do not have properly identified back pressure scenarios, you might actually undersize PSVs. Okay, these are okay. Is there any question till now? Yeah,
I have a
go ahead.
question.
Hello,
Can you hear
sir.
me?
I have one question.
One by one.
Yeah, sir.
Yes,
Can
Okay.
you?
let
Yeah.
let the let the girl ask first. She was the first to ask. Sathya,
Okay.
I guess. Yeah, Sathya, please go ahead.
So I have a question here whereby yeah, just now we look into case one and case two, right? So we selected the type of PSV, either type P or Q. So my question is, what will be the drawback if we select, by any chance we select one size higher?
Okay. It is a quite common question. Uh, okay, let us see whether somebody would like to answer before me. What can happen?
If I can, please.
Yeah, please go ahead.
So oversized PSV would cause chattering. Chattering is the, I think, most foreseen problem in the PSVs. So if my PSV size is larger than my relief loads, there would be peaks of pressure. Like the overpressure would happen, my PSV will open, and then I will be relieving some media, process media to flare, and again this PSV will close. Again there will be back pressure, and this cycle will goes on. This is not, I mean, recommended in process industry, as it can hamper the mechanical parts of the PSV. So I think this is the first, chattering is the first reason that the oversized PSV shall be avoided.
Yes, that's absolutely spot on. So because pressure safety valves act on differential pressures, if you have a very big PSV, it will suddenly release all the pressure. It will cause the pressure to go down below the set pressure very quickly, and then again there will be some buildup, and again there will be pressurization, and this can happen in cycles of seconds, and that will cause very rapid movement. Even sometimes it happens that the integrity of the PSV is lost. Sometimes the shock or the vibration is so high that the piping also rupture or the gasket leaks. That is one thing. Second is, what do you think in terms of cost? Will the larger PSV be cheaper or costlier? Satya?
Costly.
Costlier. So when you know that we are having a solution which is cheaper, why to go for a costlier solution? So both the aspects are there. You do not want to spend money unnecessarily, and even if you spend, you will not be on a safer side. So generally people are ready to spend money when they are on the safer side. In this case, you are not on the safer side, but you are adding the risk of chattering by highly oversizing the PSV. Okay. Yeah. The
Hello,
second
sir.
person who was asking, yeah.
Yes.
Can you tell your name first and then ask the question?
Yeah. I am Suhair. The question
Okay.
is connecting with the girl who asked, because the second type PSV we get the 11 inch square inch, but
Sir, your
our
voice is
requirement
not
is
audible.
like this is not audible.
Yeah, I can hear you. Go ahead.
Yeah, okay. Our required is 6 point something, and what we the next available option is 11. So why
Yeah.
can we go for the previous one with two PSVs, like we have 3.6 into 2, which is more than the so is it okay?
As per the code, it is not okay, because when that case will actually happen, you don't want to exceed that 10% overpressure. See, what will happen when you reduce the size of PSV, your accumulation increases. Okay.
Sir, that's why I need to go for like more number of PSVs.
Again, I
Because
will ask the same question. Going for two numbers, will it be costlier or cheaper?
it will be costlier, but the
Yeah.
chattering effect will not be there, right? Because we need a 6 point something, and we don't have the next option. The next option is the double, like 11.
Right.
So
Right.
which is
So
the better, like
you can go for two smaller PSVs. They will both be in service at the same time.
yes.
There also you have some problems. So there is a, term called staggering. Okay, so
Okay.
you cannot install both the PSV on the same set pressure, because then also you can face the issue of chattering, because you are not going to have 50% of them. Like if you have a required area of 3, you will not have 1.5 and 1.5, right? There also you will have some margin. So in that case also there is a problem of chattering, that one PSV getting popped and then second getting popped, and both are not heavy lifting completely because the sufficient load is not there. So there is a provision called staggering, where you increase the set pressure of the second PSV above first to prevent opening of the second PSV, and you rely on the one to take care of the load. If it exceeds and it reaches to a set pressure because of the higher accumulation, then the second PSV will take care. In this case also, you have to make sure that you are not exceeding MAWP by your factor because of the accumulation. Yes, this is engineering design which you can do. Whatever I have explained is the normal, or it is, you can say, the best practices that are followed. But yes, installing multiple PSVs is also allowed in industry, and you can do staggering to prevent chattering.
Okay.
Sir,
Okay. Thank you, sir.
sir, but
Yes,
if
sir.
our
Actually, in
set pressure
boilers,
is
actually in steam
One by
drum
one.
of boilers, I have seen, I mean, two PSVs kept at different set pressures.
Right.
So that is the thing. Yeah.
Yeah. One thing is, you have to check whether they are sized independently for both the cases. If you have, say, blocked outlet, whether your one PSV will be sufficient, or you need both the PSV to operate. Sometimes what happens, they also design one PSV for one case and second PSV for other. For example, for blocked outlet, we will have a smaller PSV, and for external fire, we will have a differential. Sorry, we will have a bigger PSV, and bigger PSV will have a higher set pressure, because we do not expect fire to happen every time, but we expect overpressure scenarios more frequently compared to fire. But if fire happens, you need to have adequately size. So worst case is the fire. For fire, you have the highest size, biggest size of the PSV. Okay. Yes,
Sir,
Rushikesh.
Yeah, so in addition to
API,
this,
just
maybe
addition to
if
this, yeah,
One
yeah,
by one,
API
yes,
please.
just additional
521.
to this, only in the boiler section, as per IPR regulations, at some pressures, you require two PSV, one as at fire case and one at block outlet that you are saying.
Correct, correct. Yeah, yeah.
Yeah.
sir,
But we usually
sir,
don't say this in normal operation. Na? I mean, API 521 says adding a supplemental PSV for a fire case when the difference of load is huge. But generally, when we see in process industry, we size a single PSV covering all process scenarios, overpressure scenarios. We don't usually
except
give
except the fire, and because we do not use fire as a, you can say, credible scenario, and we have to make sure that it is not a credible scenario by means of external factors, like if you have fixed fire protection, or such system, automatic sprinkler system, then you can have a logic that, okay, even in case of external fire, I have these things to take care, and I will not size my PSV for external fire. Because API is not an Indian body, sizing PSV for external fire is not a legal mandatory for India. Or even Asia. So if you have logic that I have a fixed fire protection, I can take the action within 10 minutes of time. I will not size any PSV for external fire case, and I will go for only the blocked outlet or control valve failure, such cases. That is also
okay,
allowed.
okay.
Yeah.
Sir.
Yes, I will now.
Hello, sir.
Just a minute. Just a minute. Just a minute. Now, raise your hand. Whoever having a question, I will go one by one. So whoever ask first will get the first preference. Rushikesh, I can see your hand.
Okay, hello, sir.
Yeah.
Sir, how we decide back pressure for the
Decide.
system?
Back pressure is not decided. Back pressure is our, as you see from the example, back pressure is our kind of majburi. Back pressure is our limiting factor. So when you are having PSVs for toxic services, you cannot vent them to atmosphere. Or when you are having flammable services, you cannot directly vent them anywhere. You either have to route them through scrubbers or to
Sir,
some dump
your
tank.
voice is not audible.
My mic is on. I think others are able to hear me.
Yes, yes.
Yes, sir.
Yes, sir.
Yeah. Yeah. So whenever you are having some equipment downstream of a PSV, there is always a back pressure, and sometimes it happens. For example, ammonia. If you have ammonia PSV, you actually try to absorb it in water under some pressure. So at that time,
Yeah.
you have some back pressure. So back pressure is not something which we create. It is created by our limitation, our process requirement, and to cater that requirement we have to take into consideration for the sizing. It is not that we want the back pressure, we never want it, we want to keep our PSV smaller. Okay,
Uh,
next is
okay, sir. And
from, let me just check
sir,
out
one more question.
one more question.
Hello.
Okay, go ahead.
Sir, how we decide the MOC of the safety valves according to our process?
So first preference is to the cheapest MOC, but if your MOC is your material is corrosive, then you try to go for the MOC which is not corroded by your process fluid. Then the next option is to have a rupture disc, that which will be your not impacting your rupture disc. For example, somebody said PTA lined or PTFE lined or even graphite, okay, or even tantalum or hastoloi. Not tantalum, I'm not sure. Hastoloi C. So these are higher MOCs which are resistant to acidic materials, and they will not corrode. So you can have a cheaper rupture disc of a high resistant material and a normal SS304 PSV to have an intermittent or very short period of time exposure to those the corrosive fluids. Okay.
Okay, sir. Thank you.
Okay. Next one is, I cannot see the hands raised now. Just a minute. Dhaneshwar.
Yes, sir. Actually, we had one case previously on. We have a reactor inside the coil is there, and cooling water is the utility for that coil.
Uh-huh.
Okay. And what happened? We have sized the PRV for the blocked outlet case at the outlet of the cooling water. If my outlet wall is closed, then I have to use that one safety. Okay.
Okay.
So what happened? Once our reaction is not going to control and it is highly exothermic, by that cooling load, it is not going to settle the temperature. So in
Okay.
that case, what is happening? Our whatever inside the coil is getting evaporated. Okay.
Okay.
So we have sized for the liquid outlet, but once it is evaporated, it is two-phase flow now. Okay. And
Right.
liquidities. So in that case, what will be the scenario for the design to be considered? At what temperature or what means for the two-phase flow? What should be the density to be protected, or how it shall be means?
Okay, so two-phase flow is really a complex phenomena for sizing, and I would say if you are having such cases, PSV is the last solution. Okay, for this case, as you said, what is your process temperature? Can you tell me the process temperature? Hello, you're
80
muted.
degrees Celsius. 80 degrees
How much?
Celsius.
80 degrees centigrade.
80. Yeah.
Yeah. So your temperature is 80. Your water will not boil at 80, right?
No, process temperature is 80, but by in some cases it is going beyond 100. that process temperature. So
Beyond
it can
100.
elevate
Okay.
my utility temperature against the boiling point. If my cooling water supplied pressure is 2 bar gauge, that's high pressure, I have increased my boiling point also, correct? So it's almost 106 degrees Celsius, it is getting evaporated, but not purely, but halfly, means partially it is vaporized and liquid.
Right.
And
So
we have not considered that scenario for the design that it should be vaporized, or in any cases it will be vaporized like this.
what is the design pressure of your cooling circuit?
I think is 4.5 bar gauge, or
4.5 bar
5 bar gauge, 5 bar gauge.
Are you going to reach a temperature where your water is going to get a pressure over 4 point for more than 4.5 bar gauge? You have to exceed around 130-135 degrees centigrade. So is
Yeah.
that the temperature that you are going to reach in your reactor?
No, but due to some vapor pressure, it is vaporizing. Not on
It will vaporize.
total.
I agree.
Yeah.
I agree. Do you?
Yeah.
The first question, see, we are all engineers. We have to think in a
Yeah.
stage by stage manner.
Yeah.
So you
Yeah.
have a water. Let
Okay.
us think, why do you even need a PSV if your water circuit is rated for 4.5 bar gauge? Your temperature
Okay.
is never going to go above 130. Your maximum achievable pressure will be always less than your design pressure. You do not need a
Yeah.
PSV.
Yeah. 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 Yeah.
Okay. Second case, you might be having a temperature wherein it would have been more than, say, for example, your reaction temperature might be 200 degree, and your
Okay.
circuit rated pressure is 4.5. In that case, your case becomes credible that okay, the holdup
Yeah.
can boil up,
Yeah.
holdup can get heated in blocked outlet condition, and it can create a pressure because of your temperature.
Temperature.
Okay.
Temperature. Yeah.
Now this is a case of blocked outlet with heat on. It's a thermal expansion case, right?
Okay. Yes.
It's a case of thermal expansion. Now if you do the
Yes.
calculation, you will find out that for thermal expansion, even 1 inch size PSV is sufficient, even though the flow is one phase or two phase, because
Okay.
the rate of pressure
Okay.
rise because of the thermal expansion is not very high. So for
Okay.
thermal expansion cases, in general, 1 inch PSV is always sufficient. Third
Okay.
thing,
Okay.
if you still want to do this analysis, you can do this, but it is not really very simple. You can do calculation for two-phase flow. You will need some data for that. Maybe what is the vapor fraction, what is the liquid. You will have to make some assumption, and you can do the
Yeah.
calculation. But in your case, as you have mentioned, this case is handled by many industries, and 1 inch thermal expansion rated pressure safety valve is sufficient, because in this case, first, you are not going to achieve that because your temperature is not so much. In second case
Yeah.
also, your rate of rise of temperature will be very slow, because water has a high CP. So it has a CP
Yeah.
of
Yeah. Yeah.
4.18. It needs a lot of heat, so its rate of heating is the rate of pressure rise, right? Because rate of temperature
Yeah.
rise will
Yeah.
be proportional to rate of pressure rise.
Yes.
So
Yes.
in this case,
Yes. Yes.
your beta will come into picture, because you call it as coefficient of thermal expansion. And I have seen
Yes.
many calculations, 1 inch safety wall is sufficient for this case. Okay, you need not to go for
Okay.
two-phase flow and all these things.
Okay. Okay. And we
Okay.
did also the calculation for on Aspen also by considering some vapor fraction, and we are also coming near around the same orifice area, but
Right.
at the point of vendor there are some different opinions. We have set up that one.
Okay,
Thank
thank
you.
you. So next one is Mahmood.
Yes, we just saw the type of PSVs, and we saw there is one pilot type of PSV, and we have two types in pilot. One is pop-up action, and we have modulating type. So
Okay.
when do we use modulating is my question. And but I have one more question. That is, there is something called as CDTP, cold differential test pressure, and that is usually applied for this
Yeah.
conventional and balanced values.
Yeah.
So can you please shed
So
some light on that?
okay, I will explain the CD cold differential test bench pressure to you. The second part that you said regarding the modulating and Which one? Direct and modulating, right?
Yeah.
I have not actually handled direct and modulating, so I'm not the right person to provide expertise on that, because I do not want to share an information where I'm not sure. So I would skip that question as of now, because I'm not very clear on that. For cold test differential pressure, see, we use PSVs at different temperatures, right? We use it at 50, 100, 200, 300, sometimes even higher. But we have a test bench at atmospheric pressure. So whenever you have a workshop, you try to test a PSV that whether it lifts at certain pressure or not. So what happens when you test it in a test bench? It is having atmospheric temperature, and when it is operating in a reactor, it is having elevated temperature. So as you know, the property of metals get soft when they are exposed to higher temperature, right? So when it will be exposed to 200 degrees centigrade, we have a spring with to control the opening of PSV. That spring will get soft. The K value, or you can say the coefficient of what do you call compression, that will be lower, because the temperature is higher. It has become soft, and it will lift at a lower pressure compared to what you have tested at the test bench. To avoid this concept of cold bench differential temperature has arrived. So what they do, if you have a PSV which is expected to operate at say 10 bar gauge at 200 degrees centigrade, how much pressure it should operate at in the cold condition, that is derived by means of a simple calculation, that what is the temperature difference and what will be the operating temperature at uh, room temperature, for which the operating pressure at 200 degrees centigrade will be matched. Okay, and that is the concept, and we do this calculation and check at that CDTP value in the workshop. Is it clear, Mahmood?
Okay. Yeah. Sure. Just one more small question. Just small question. They we sized one PSV for one of the column, and it the blowdown was near to 7%. I mean the difference between maximum operating pressure and the set pressure. So yeah,
Mhm.
is within 7%, marginal you can say. So
Okay.
is there any limitation of blowdown being 7%, or I can go less than the 7% if I want to use balanced below?
I think for blowdown there have been clear guidelines in API. I do not remember by type to type, but I think 7% is something which I have read the maximum, that you cannot go below 7%. This is what I remember, but I don't think it changes from type to type. For balanced below, it is only the back pressure and not the blowdown. We
Okay,
do
I
not
think
have a
modulating might differ, have some different values, less values of blowdown because of the characteristics of how it operates.
as I mentioned earlier, this I'm not sure about modulating type
Okay.
because I have not never worked with it. So maybe you need to seek more expertise, because it is not possible that everybody will know everything.
Yeah,
So
sure.
I can tell you that I am not very sure about modulating PSV. Okay.
Okay, yeah. Thank you.
Okay. Kushwant Kumar.
Yes, sir. Initially, you told two PSVs can use for one equipment. So for one is high set pressure, one is some compared to one PSV, another PSV is at the some low pressure. So what is
Mhm.
the minimum difference requirement between set pressure different two?
I don't remember it by heart, but it is in some percentage. I think it is around 0.5 or 1%. I'll have to check the code. Maybe you can also check it in the code. There is in the staggering of PSV section, you can find that. So they call it
Okay, okay.
staggering of PSV. So what should be the
So
difference? Staggering, STAGGERING, staggering of PSV. I'm not very good in remembering the numbers, but I know the concept. So you can refer to that. What are the options available for staggering? If I remember correctly, it is around 3 to 5%, but I don't want to
three to
guess.
three to 3 to 5% difference or
Offset pressure, offset pressure. Yeah,
three
but
percent
I'm
of high set pressure you're saying or low set pressure difference?
So if you have a set pressure for one PSV, you take some percentage of that PSV and set another.
Okay,
But
1%.
they
The
they have
difference.
this, it's difference. They have this just to make sure that you do not have both the PSV at a
Pop at a time.
very popping at a time. So that is the concept. I'm not sure about the number. Please check it in the standard.
Yeah, okay. Okay, so
Okay.
so
Suhair.
just okay. So then after
Yes, sir. My doubt is type of PSVs, choosing the type of PSVs. You said because the criteria is the back pressure, the percentage of the back pressure, the build-up back pressure and the superimposed. So is it okay with the if the pressure ratio is less than 10% and we can go for a pilot PRV? Is there any other criteria we can choose the pilot PRV with less back pressure? Because I saw some in my
Pilot PR,
plan.
yeah, yeah, yeah. Pilot
In my plan,
PRVs are
yes,
considered leak tight. They are
leak tight.
considered leak tight. So if you have a very toxic service, you said that you saw something in the plant. What
Yes,
is the
but
service?
the service is steam. It is the 10 bar steam with a 185 degrees Celsius. But the PRV back pressure is less than 10%. The total back pressure, but they go for the pilot operated PRV. So that's why I ask: is there any other criteria other than the back pressure ratio to choose a PRV?
In this case, I don't see any reason, because this is a very common case in industry, and it is generally because steam you can vent anywhere, right? So
Yes,
generally
it is
conventional.
bending to the atmosphere, so the back pressure is like nothing is there.
Correct. So you should actually ask this question to the person who selected. Why did you selected pilot operated if you have the option of conventional? I don't think there is
So,
any reason except
so what could be
uh,
the other reason, like apart from the steam service, any other service, like you said, the type.
yeah. So for if you have something which is very toxic, you do not want to have any kind of premature popping up of PSV, then you use pilot operated one. Then the second is when you have very close design pressure, and so you do not have tolerance. Okay,
Okay.
you want to have very high set pressure of a PSV, and you do not have sufficient tolerance,
Okay.
then you can choose pilot operated because
Pilot.
it operates precisely.
Yeah, I think maybe this could be the reason. The tolerance
For
is very
steam, i
less.
don't think i don't think for steam it might be the reason, because
Okay.
generally for steam services they get it IBR approved, and these people, IBR people themselves, ask for a lot of margin in design. So I'm not sure, maybe some selling tactic or some missed
Okay.
fundamental
No,
might
sir.
have been.
On top of this addition, I would like to top one thing. If this PSV is designed for pilot operated, maybe they are going to planning a waste heat recovery. If your PSV exhaust is getting arrested by somewhere by like deaerator or any heat exchanger, in that case they have might consider the back pressure of that line itself.
But he
That
mentioned
might
at
be
the
a case.
start itself that
Yeah,
it is
but
venting to
the
atmosphere.
PSV is venting to atmosphere. That's it.
Yeah.
No, no. Right now it is atmosphere. I agree. But in the
Okay,
Maybe
okay.
the
expansion
future,
I
phase,
got,
maybe
I
the
got you.
future
I got
plan.
you. Maybe in the future
Maybe.
yeah,
plans. I got you.
Right.
most
Okay,
of the
thank you.
plants rated for the boiler higher capacity, so that planning for the waste heat recovery or the deaerator to condense that much of extra steam which is going outside the atmosphere. In that case, pipe
Gnaneshwar,
routing for that venting point.
Gnaneshwar, I
Yes,
actually
sir.
do not think that this should be the design philosophy, because see,
Okay.
popping up of safety wall is not something which you expect to happen, and waste heat recovery
Yes,
is
if
where
that
waste heat
PSP is
recovery
on
is.
the turbine exhaust line, it is. No, what happens,
Mhm,
sir, if that PSP is on the turbine exhaust line header,
mhm,
when suppose any process stream is cut directly, why
mhm.
suppose any wall is closed. So right now the effect is on the turbine, but customer is take effect on turbine itself. No, so will it better to exhaust the steam outside the atmosphere.
Okay,
So
but
in that
what
case,
he
for a
mentioned is
mini,
it's on the
yeah,
plant header. not on the
Okay.
turbines. I'm not sure. Do you have turbine, Suher?
Yes, sir. It is going to
Yeah,
the
absolutely.
steam turbine suction.
It's going to the turbine. Then it makes sense. So Dhaneshwar has a very good point that because they want to prevent kind of
Yeah.
higher load on that, they have selected this thing pilot operated.
Yeah, the
Okay, so
the main
these
reason here, if your steam pressure back to the turbine itself, then the turbine having a back pressure, so it might be getting effect of the condensing of that superheated vapors into turbine, and turbine won't accept the water inside it.
so
That's why maybe
he
the
might be
case.
sending it upstream, like maybe to a steam drum where it
Yeah,
the
yeah, yeah.
shock can get
That's my
absorbed,
understanding.
and then
That's understanding.
there is some.
Because it is a back pressure turbine, and the header is going to the MP steam header.
Okay,
Uh,
so these are niche application. These are specialized application where this
Yeah,
makes
yeah,
sense, but not for the general application. Thank you, Dhaneshwar,
yeah,
for your insight.
yeah. Thank
Thank
you,
you.
Yes,
Thank you.
Vivek.
Sir, so I have question regarding rupture disk that we have freedom in choosing the set pressure of PSV. So we have 3% criterion suction line and back pressure criterion discharge line. So if set pressure complies it, then we can reduce the set pressure from the design pressure. But in
Yeah.
case of rupture disk burst pressure sizing,
Mhm.
we take it with respect to operating ratio and burst tolerance and manufacturing tolerance. So it is
Right.
not so it is not related in any sense to the design pressure. So
Yes,
I want to share
because see,
this.
once the rupture disk opens, there is no resistance. Okay, why do we limit 3% pressure drop in the inlet line and 10% in the outlet line? Is to have a stable operation of PSV. In case of rupture disk do not operate; it just burst. That's why these parameters are not there. But yes, in rupture disk, you have a different problem that if you have a pinhole in the rupture disk and if your pressure equalizes upstream and downstream of the rupture disk, then you may have a problem that your rupture disk will not burst completely because it has not reached its differential pressure set point. Because say there is a rupture disk, it burst at 5 bar gauge. 5 bar gauge pressure is available and upstream and downstream. The differential pressure becomes 0, so it will rupture only when the differential pressure exceeds the set pressure of the rupture disk. So for that there is an arrangement for sensing the pressure on the downstream of the rupture disk, but there is no such criteria in terms of pressure drop. Okay.
Okay, sir,
Yes.
and one more question that is so so in like in rupture disk. Actually, I don't remember it. Sorry.
No problem. You can even share your questions later on chat with your email ID. I can respond to that. Okay. You can put in
Okay.
the meeting chat with your name. I am not sure I will
Sir,
be able to access later or not. Better to ask here only. Okay, Mahesh.
sir,
Mr.
sir,
Mahesh. Yeah, go ahead.
sir, I have a
Hello.
question.
Mahesh is asking. Please, please wait
Yes, sir.
because
I just
I'm
have a
going with
small
the sequence
question.
of hand raised. Yeah, go ahead.
Raise किया है भाई.
I have small question regarding sizing of the PRV, in which we use KD, coefficient of discharge. As you said, it depends on the if we are using safety valve without rupture disc and with rupture disc.
Mhm.
Is it depends on only both of them, or is it different for PSV and PRV? Means for liquid,
No. It
vapor,
is not.
steam.
It is not different. Only it is when there is a combination, you have to consider coefficient of discharge.
Okay, is it a fixed value like 0.975 and 0.67?
Yes. Yes, it is fixed as in code. If the PSV is manufactured with that code, you can use that value. You can use lower value to be conservative, but not higher. Okay.
Okay, okay, okay. Thank you.
Yes, Harsh Thakur.
Hello, sir.
Harsh,
Yeah, I have the
yeah.
question. Yeah, I have the question regarding the orifice size nozzle. Like, is it mostly based on the pressure and or is it based on the relief load? Because if I assume the orifice as a nozzle, so then like if the pressure would decrease once it passes the nozzle. Is it so? Like am I lacking in something in knowledge?
Uh, See, this nozzle is not kind of the nozzle which you are thinking about. The nozzle which you are thinking about is pointing towards the center, which increases the
Mm-hmm.
velocity. In PSV, it is diverging kind of nozzle. So it remains straight and then diverges inside the bonnet. So it is not going to increase the velocity for sure. So it is not that kind of nozzle. It is just a extension of your. So you have a nozzle on your vessel. You have a flange on PSV, and then the pipe connecting to the PSV. So that's the nozzle. It's not something which is pointing kind of thing. Okay.
Okay. Mm-hmm. Thanks so much.
Okay. Yes, Kushwant. So this will be the last question, I guess. It's already 10 minutes past 10.
Yes,
Yes,
sir.
Kushwant, with your
Uh,
last question.
Sir, I have one doubt regarding the installation of the PSV. I have a case,
Hmm.
one working PSV and another is standby PSV.
Hmm.
So, can I put the isolation walls at the downstream of PSV to isolate standby thing?
Downstream,
Upstream, sorry, upstream.
upstream.
Yeah,
Is it on? It is on two different nozzles, right?
yeah, two different nozzles.
And they are both rated independently for the worst case event, right?
No, no, I'm saying one is working, another is standby.
So, s you have considered it standby with some assumption, right? So, for
Yes, yes.
example, it needs to relieve 10,000 kgs per hour. So, both can
Yes.
relieve 10,000 kgs per
10,000.
hour independently.
Yes, yes.
Then you can isolate one PSV and let the other be standby. It is allowed as long as they are independently rated for the worst case scenario. It is allowed, no problem. That is the
In,
purpose actually for giving those two PSV, that whenever you are using, whenever you want to do the, so there are certain processes which are, continuous processes. They cannot take shutdown for
while
years
PSV
together.
maintenance, yes, while
Yeah.
PSV maintenance, we
So
can't take shut on that.
correct. So that for that they provide needle walls, which are tight shut-off walls at the PSV upstreams, and then they remove walls, do the PM, and then reinstall. It is allowed, and for that purpose only standby PSV is provided. Only thing is, do not assume that it is standby as long as you have a document stating that we have two PSVs and even the single one can work and is sufficient for our worst case. Okay, do not
Yes.
assume, ask for a paper.
Okay. Then after,
Yes,
in the downstream of the PSV, any isolation wall is requirement generally is required.
I'm not sure where your downstream is going. If it is going to a common vessel
Header,
where your
yes, common header. Yes.
then you need to isolate, because if the second PSV pops up, there will be some material coming back from that line, and if you
Yes.
have keep that open, then it will enter the PSV, and if you are having this line open without any valve, then it will exit from that port without intention. You do not want your material to come out from the flanges of which are connected to PSV, so you should isolate them where it gets connected to the
Okay.
header.
Okay, okay.
Sir,
Thank you.
Yes,
hello.
Chandrani. Chandrani is the next. You need to raise your hand. I think Kapil raised and then lowered his hand. Kapil, you can go. You can
Sir,
ask your question. Yeah.
actually, I have a question. I have a benzene column which have
Hmm.
three PSV. So,
Okay.
our licensor is Lamas, and it's told us that we given three PSV because if two will get out of service and then one will work, and it is mentioned in API 521 that a standby PSV should be there if you have don't have one extra vessel for that. Is it like mentioned this in 521 API that it's necessary to give three PSVs?
So I do not fully understand your question. You have benzene column, you have three PSV. How many of
Yeah.
them you need for the worst case scenario? Two at a time or three at a time or one at a time?
Sir, according to Lomas, only two will be in line and one is in standby.
Two in line, but do you need both of them?
Yeah,
Yes. Okay.
because because they
Okay.
have said that yes.
Considering you need both of them to act simultaneously, so they are staggered PSVs. He is right in saying that third one is given so that you can pair a combination. Like if there are 1 2 3, you can have 1 2 in operation, 3 in maintenance, 2 3 in operation, 1 in maintenance, 1 3 in operation, 2 in maintenance. So this is possible because you need two PSV all the time running condition to mitigate the worst case. It's allowed, no problem.
And sir, which type of Orpheus is there in PSV?
This type of
Orpheus.
orifice.
Yeah.
All PSVs have orifice inside. The
T
opening is called
type.
orifice.
T type.
T type. Okay.
Yeah.
I don't fully get your question. What do you mean by
Actually,
all
sir,
of them are okay, I got your question. I got your question. You have the maximum size. You have the maximum size already. That's why you need two.
Okay.
So
Okay.
T is the
Okay.
highest size. So I got your question fully now. So vendor is not able to provide one PSV because your load is so high that it needs two PSV at a time. And he has given the third one that also will be T type because you want two PSVs working at a time to cater your
Okay.
worst case load.
Okay, okay. So why not he is given only like why is given three PSV? Like he can give two big size PSVs.
It again boils down to the cost. So
Okay, okay.
sometimes three smaller PSVs can be cheaper than two bigger PSVs. So he has kind of played a trade-off between cost and availability.
Okay, 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 sir. Okay, thank you.
Yes, Chandrani,
Sir, how we can calculate relieving load?
how we can?
Calculate relieving load.
Okay, so for calculating relieving load, there are certain cases, as I mentioned in one of the slides. What can go wrong in your system? You can have a blocked outlet, you can have an external fire, you can have a exothermic reaction getting uncontrolled, a control wall malfunction. So first of all, you will have to identify what are the cases that can go wrong. Then based on that, you will have to do the calculation. For example, if control valve fails, it can feed the steam. For example, it is a steam control. It can feed the steam at some maximum possible rate, which will be dependent of the CV of the control valve. And when this mass flow rate is available, you know, for example, we were talking about benzene column. If you know what will be the maximum flow rate of steam to the reboiler in benzene column, you can find out what can be the benzene boil up rate. So in case of your control valve malfunction, that much benzene will be boiled. So that becomes your load for the relief valve. So by this method, you have to calculate for all. For external fire, there are equations that, okay, this much heat load will be impeached on the column or reactor. What will be the heat transfer? How much will be the vapor generation based on the your volatile component inside the reactor, its density and its vapor pressure, its CP, the heat gaining capacity, and from that you can find out the mass flow rate. So for different cases, the equations and the methods are different, but to select a PSV, first thing is to find out the mass flow rate. So I have given you insight for two. You can check for others. There are references also. Okay.
Okay, sir. Thank you.
Yes, Sujit and Shivraj, two questions are there. Now, please do not raise any more hands. If you have questions, put them in chat. I will put them in chat with your email ID. I will respond. I will try to respond to those questions because we have exceeded by 18 minutes now. Okay, Shivraj first and then Sujit. Shivraj, you are on mute. Okay, Sujit, please go ahead.
Yes, sir. Sir, I have a very
Hello.
basic question.
Shivraj, you
Uh,
will have to wait now. Okay,
Okay,
Sujit.
that's fine. That's fine.
what is the significance of relieving temperature? Normally, it is calculated.
Uh-huh.
So, how do I I mean, what is the significance? Relieving pressure, I understand everything. Overpressure,
Uh,
everything I understand. But what is the significance of this relieving temperature?
You saw the calculations. You
No,
have
sir, I
you
didn't. No. No.
Okay, so in this webinar, you might get the recording later also. We went through the sizing equations. Okay, in that sizing equations, you have this temperature as a parameter. Why? Because mass flow rate is dependent on temperature, because as the temperature changes, density changes. So to have that factor in the calculation, relieving temperature is important. Also, it is important for selecting the internals of PSV. So there are some soft internals also, like seat or some bellows or gaskets, whether
Okay,
they are
okay,
suitable
got
for
it,
that
got it.
temperature or not. For that, you need relieving temperature. Yes,
Good.
Shivraj, with the last question. Yeah.
Yeah. So this question is a bit of the session. Please try to answer if it is possible.
Just
Actually,
wait a moment, Shivraj. Till the time
Mhm.
I finish this question with Shivraj, others can put their feedback for the session in the chat. How did you like, or what did you missed in the session? Like, do you find this insightful, useful for you? How was your experience? How whether I was able to answer your questions? What should have been better? Please give your feedback in the chat, and I would appreciate, because it's no cost. You can say it's a free webinar. At least this much I want you to do for me. Put your feedback on the chat. Positive, negative does not matter. Just put your feedback. Yes, Shivraj, go ahead.
Yeah. So the question is related to the latent heat of vaporization for multi-component mixtures. Okay. So whenever we calculate latent heat of vaporization for single component, it is easy. We can go by the standards. But what about the multi-component? Okay. So I was digging into it and I found that we need to do multiple flash calculations for that. Right. For we can go with S-Pen also. Can you just, if it is possible, can you just explain a short bit about how we can do that calculations in Aspen, like multiple flashing, how we can do that?
I have not done PSV simulations for flashing services in Aspen, so I'm not able
Mm.
to answer this question in terms of simulation. But
Okay,
as far as I know, this latent heat is a colligative property, right? So it depends on the composition, correct? So for
correct, correct,
example,
correct,
if you have, say, water and ethanol in 50-50, so the
correct,
latent heat will be 50% of water and 50% of ethanol. So even with all the compositions known and all the latent heats individually known, you
Mhm.
already have uh, a latent heat of mixture. Like we have m average, no, molecular weight average. So
correct,
what we
correct,
do, molecular weight of one component into fraction, mole fraction of that
correct, correct,
component, or
correct,
volume fraction. So by this method you can find out the latent heat, the average latent heat for the mixture. You do not need Aspen for these things. Now this is possible that you might have available latent heat at some temperature and your mixture is at some different temperature. That
correct,
can cause a small error, because latent heat is not highly affected. If you see 15, 20 or 40, 45 degrees difference, latent heat
correct,
does not change by very large fraction. So
correct,
you can
correct,
do
correct.
even the
Yes.
manual calculation, and I'm not sure about Aspen. I have never done it.
There were, in one of the case, there were 12, 13 components, a mixture of
Mhm.
components.
Mhm.
And I was just going through that, and what they did is, I will just give you an idea. It will be information for everybody. What they did is they took that whole composition into Aspen. They selected a fluid property, and what they did, they selected 4 to 5 multiple flash runs. Okay, and they started vaporizing a fraction from that, like fraction of vapors from
Okay.
that. And at the last, whatever was the heat required to vaporize. So they used that, and they calculated on the basis of the flow rate. They calculated the latent heat, which is required for doing that whole calculation. Everybody can dig deep into that. So it's just for information. Okay.
Okay, so if you
So.
just for my information, if you
Mhm.
have you tried manual calculation, or that was the only thing that it was done?
No, no. Actually, manual calculation, because it is very dynamic thing. Because there are changes in the temperature. But this is mainly for the fire case. To be no, to be very specific of this, because in the fire contingencies, there are some components which are very light. They get evaporated first. Okay, then comes the heavy components. Okay, which have very low latent heat. Correct. and
Right.
and depending on that, the relieving conditions differ. So
Right.
doing it manually, it's a bit tedious. It is not impossible, it's a bit tedious.
Okay.
And doing through Aspen, we get direct figures how we
Right.
can do that. Yeah,
And this
so
is a bit of dynamic also, because
correct,
the
correct,
first component to boil off will be the lightest one, and at that
correct,
time the heavy component will still have not boiled. Even there is a
correct,
difference
correct,
in boiling point also.
correct. Yes,
So
yes.
in terms of static, that how much heat will be required, that will be easily calculated by the method I shared. But yes, for you, if it is you want to find out what flow rate or
Mm-hmm.
what vapor rate is going to
Mm,
come, then
correct.
dynamic simulation in Aspen will help.
Is
I'm not expert
correct.
of Aspen, so I'm not able to share my insight on that.
That is
Okay.
that is totally fine. I thought you might have some insights over that.
Okay. Yes, Bhumit.
That is totally fine.
Thank you, Shivraj. Bhumit.
Yes,
Yes.
yes. My question is with regards to the external PSV, what we install in the discharge of the PD pump. The scenario what I wanted to know about is our system is like PSV is going to get affected with high back pressure because the outlet of the PSV is routed to the product tank, suction tank we can say, because it is a
Okay.
product pump. So, like, do we consider bellow failure as a scenario, or like in HAZOP, is it like maybe if you know something about failure scenario, can we
Bellow,
consider in the time
bellow
bellow
failure,
failure?
where bellow failure? Which bellow failure?
PSV sizing, bellow rupture. I mean to say, bellow rupture case, do we consider it?
So for the PSV you are asking, or for some
Yes.
other?
No, no, PSV only, because since bellow, see, this system is under in terms of number, I would say discharge pressure of pump is around 90 bar. Set pressure we will set accordingly, and back pressure of 40-45 bar is exerting on the PSV. So, like, do we consider the bellow rupture case in the sizing?
So if you are talking about the bellow of the PSV itself,
Right. Yes.
okay, but then you have to check that your bellow rating should be higher than your expected design pressure, expected incident pressure. So that is the thing, because if you have sized the PSV for the gear pump or the positive displacement pump
Hmm.
discharge, then you have already
Hmm.
considered for the flow rate, but you do
Right.
not want to get it ruptured from the reverse direction, right? Because
Right.
outlet will also be under pressure, and bellow
Hmm.
will also be under pressure from the outlet pressure. So you have to make sure that the bellow is designed to withstand that pressure, because that is not a failure. It is going to be in that pressure every time, all the time.
Throughout.
Correct.
Okay.
So if you do not have the bellow designed for that pressure, go for some other design. In this case, I would say, why do you go for balanced bellow? It's a liquid service.
Mm-hmm.
Uh, if you are not having much issue with the back pressure, better to go for conventional design. Why to increase the risk for this bellow? Unless and until there is some material compatibility related issue. And
No,
second thing
only thing
is,
is we are taking it back. It is a product. We cannot lose it. So it is
okay,
taken back to the pressurized source. So back pressure is exerting.
okay, back pressure is there, so you want a balanced bellow. Okay.
Yes.
Yeah, so check for the bellow design pressure,
That's
and it
only
should,
design we have to verify. That's it. That is the only.
and by
No.
default it will be there, because see, your set pressure is higher than your back pressure.
Right. Exactly.
So if bellow is withstanding your set pressure, it should definitely withstand the back pressure. But get it confirmed from the vendor. Okay.
Okay. Okay. Clear. Clear. Thank you. Thank you.
Okay, so if there are no more questions, you can continue to put your reviews in chat. Let me go through if somebody has put it already or not.
Sir, it has very informative and you have a very good command on this topic. Just wanted
Thank
to
you.
your good name, sir.
As per the policy of this game club, I cannot reveal my name.
Okay,
So
okay.
yeah, you can connect with the game club if you have any specific requirement. For example, you want to get something designed or some specific industry related problem, we want to get it
Okay.
solved. You can get in touch with game club. You can share that the person who gave the presentation or gave the training on 21st Feb, we want to connect with that person. They can reach me out, but I cannot violate the organizational policies. Please route
Okay,
your
sir, no
inquiry.
issue.
If there is inquiry, please route it through Chem Club. Okay.
Yeah, yeah. Sure, sir. Sure.
All right. Okay, then have a great day ahead, great night ahead, and
Yeah.
thank you so much for attending. Bye bye.
Thank you,
Thank
sir.
you, sir.
Thank you.
Sorry for delaying.
Thank
No
you.
problem.
Thank you.
Bye
Thank you,
bye.
sir.
Thank you, sir.
Bye bye.
Thank
Good
you,
night.
sir.
Good night, everyone.